Our next speaker is going to talk to us about, you guessed it, robots. Please welcome Christian Piechnick.
So, hi everyone. The moderator already woke you a bit up with questions, but who would agree, hands up, who thinks that robots or robotics is one of the central topics that will drive our daily lives in the next 20 years? Yeah. I think we've all grown up with, not working a clicker now. We've all grown up, at least my generation, with a picture of robots which was pretty much driven by what we know of science fiction movies and literature. I think even for the older generation in the room, there has been the topic of robotics and intelligent machines that are automatically able to solve tasks, to kind of help us as a tool in our daily lives quite for a while. And even though we all have a very disordered picture from reality, I think we have made significant improvements on robotic technologies over the course of the last 20 years, but we're not there yet, I would say. So in order to come to a future where really robots drive innovation, we have to look at where we currently stand and what are the challenges. So what are the driving factors that will make robots a mass product, that will bring robots to every home, to every company? And in order to do that, I would like to take you on a very brief journey on comparable technologies that changed our daily lives in the last 20 years. So if you look at the development of PCs, started in the 40s with the first kind of mechanical PCs, then moved via mainframes, so very large, very expensive computers for very specific tasks, to the first personal computer, and now we have a huge variability on different sorts of devices, on sizes and everything. If you look at the global number of installation on PCs, I think the question that comes into mind, which brought PCs from 1 million range to 1 billion range, is the question on what actually led to the takeoff of installations at that time frame. And what I would claim is that software companies, and especially Microsoft, and all people who do not like Microsoft here, I'm very sorry, but those were the guys back in the 90s making PCs a mass product. And if you look at what they have done to robots to PCs back at the time, I would say it was 3 major contributions they have made. Of course, they didn't invent graphical user interfaces, but they were the guys bringing it into reality. So a user interface which is rather easy to use. Second contribution was at the beginning more or less not so perfectly working driver system, but at least you didn't have to solder in order to compose hardware. Today, you have, if you're using a printer, you don't care whether your printer comes from Epson or Canon or whomever. You have a driver system, you have plug and play, you have standardized printing dialogues. You don't care where your printer is from. And they have provided development tools for all the creators out there to create content, to build on top of the platform. Now, looking at robotics, very interestingly, professional robotics has started in a nearly similar time frame. So starting with first mechanically programmed robots in the first Ford factories, to smaller and more versatile robots, to programmable robots. And today we equally have this huge variety and landscape of collaborative robots, different shapes, different sizes. If you look at the install base of robots, of industrial robots, if you're from venture capital and look at this curve, people always like this because it suggests an exponential growth. The key message here is if you plot both lines at the same chart, you still see that robotics is a global business which is more or less a Mickey Mouse business compared to any other industry. And really the question is what we need to accomplish here to kind of get this takeoff in terms of adoption rate of robots. And if you question whether or not there is space to not talk about 3 million installed robot arms, but 300 million robot arms, there is easily a world just in manufacturing where, as every white-collar worker today works with a PC, every blue-collar worker works in harmony with a robot. But in order to get there, we need a fundamental shift in kind of how the technology is brought. So the question is, why is this so fucking hard? And this is a 2022 very typical user interface of a robot. Every robot manufacturer having their own proprietary programming languages, all coming from the 80s. Software delivery is far from anything you know who is not from our industry. So maybe a very brief story. Earlier this year, I was at one of our partners which are building robot cells for large automotive customers. And there was an application engineer on the shop floor who stood in front of a robot super frustrated. And I was walking over to him and asked, like, what's up? And he told me that he's currently doing a project for a very large German automotive factory. And he needs a software package from that robot manufacturer, which was KUKA, by the way. And he said, unfortunately, delivery time for the software package is 14 weeks. And I was like, all right, is this still in development? And he said, no, it was released like 2 years ago, but still they have a delivery time of 14 weeks. And I said, how does software have a delivery time? And fact is, you can either get it on USB stick or CD, and due to the chip crisis, they're short of USB sticks, so they have to burn everything on CDs, and because everyone's getting shit on CDs, there is a huge backlog on burning CDs. That's why you have to wait 14. And that's a reality in manufacturing, bringing software to shop floors in 2022, right? So why is this so fucking hard? I don't want to go into detail too much, but if you today own a factory and you want to either get a full line or a single step being automated, you go to an engineering company, and what they will do is they will build a customized solution for your production cell. They look at your problem and they design something with engineers. And this all boils down to a robot, a tool which is mounted on the robot, can be a gripper or some kind of weld gun or whatever, sensors like cameras, PLC systems, and also integration into cloud systems. The challenge here is, with every single logo you choose, you buy into a completely different technology stack, different programming languages, non-standardized interfaces, so every single solution is tailored and custom-made, super expensive. So it was 4 years ago where I founded a company called Wandelbots. We are based in Dresden, so not the typical startup space you would imagine, but we have, in the last 4 years, we have grown to roughly now 180 people. We're active in North America and Asia and in Europe. And what we basically do in order to democratize robotics, so to build technologies that enable everyone to work with robots in industrial manufacturing, but also in other use cases like cooking, is we bring together state-of-the-art from other technologies like connectivity and merge it with cutting-edge user interaction technology in the robotics space. So one of our products, for example, is a device called TracePen, which is a physical handheld device where you can basically demonstrate a task by example, which has exchangeable tip to mimic different tools. And you can give this tool into the hand of a welder, and the welder can demonstrate a robot how manual welding would look like. What we do on the software side is based on human demonstrations. We can learn the application and then generate what we call skills. So those are applications which can be run by a robot. And then we provide state-of-the-art, cutting-edge user interaction techniques where you can basically adjust and fine-tune what was learned in order to adjust everything. And then you press a button and compile code out of that, which then makes a robot automatically do that. So what was previously being done by experts can now be done by craftsmen, and it's not being done in hours, it's done in minutes. Now, second thing is connectivity of robots, and this was a super cool demo we were doing with Satya Nadella, the CEO of Microsoft, where he was studying at least a bachelor in mechanical engineering, so he knows robots roughly. And actually what Satya was able to do is basically teach a robot sealing application, so it was PVC sealing over a distance of 8,000 kilometers based on an Azure deployment. So we had a video connection to a robot being situated in Germany, and from Redmond he was able to basically teach a robot to apply PVC sealing. And maybe...
We are a premium manufacturer. Our new 5th generation electric drivetrains sets standards. Our biggest challenge so far is the transformation from the combustion engines to the new electric drive systems, which require completely different production processes.
We choose especially Azure Machine Learning to be part of our solution because it has a rich functionality and also with the computational power provided by NVIDIA's GPUs. For the trainings of our models, we are using Azure Machine Learning and also NVIDIA VMs.
The no-code approach is the key here. The solutions are designed as a self-service. The complexity lies in the back-end. The user does not need any specific IT knowledge.
After the robot has taken the pictures, they are transferred to Azure for the model training. There we use our RCV labeling tool in the RCV cockpit to create a project, to label the pictures, and then also train the model. And for this connection to the model training, we are using Azure Machine Learning and also NVIDIA VMs. The models are deployed on NVIDIA GPUs on the shop floor that provide the computational power that is needed to realize the corresponding response times. The RoboSpectre solution combines the strengths and abilities of the included partners Microsoft, NVIDIA, Robotron and Wandelbots. The result in the end is a highly robust and automated inspection solution. It adds much benefit to flexibility and agility of the whole production.
Our production system is cutting edge. We drive innovation. We rely on effective applications that can be integrated cost effectively and flexibly.
So this is the very first application where you have a really connected robot which is doing quality inspection for the electric engines at BMW factories. So instead of buying visual systems which need weeks to set up and cost multiple 100K euros, basically you mount a camera to a robot which is taking pictures which are transferred to an on-premise cloud environment, being evaluated on machine learning algorithms, and within a day you can train that robot to do inspection tasks at a 99.9% of accuracy. So instead of basically building super custom solutions for every single technology space, what we are basically building is a universal operating system for robots, basically taking away all the heterogeneity and trying to provide cutting-edge and state-of-the-art development environments for all the creators out there that would like to join this journey and would like to build stuff for the robotics industry. And this does not necessarily mean manufacturing. There are a lot of folks running around having the idea to open up robot restaurants, to use robots for painting. There are so many other use cases out there. So what we are basically building is a platform layer, not only interaction technologies. And what we do is we integrate with all the major robot brands, we integrate with all the major tool makers, we integrate with all the major sensor makers, providing one uniform interface for that. And of course, we are building our own products like Wandelbots Teaching on top of that. But we are now also start to open up our technology platform for all people who are interested and would like to build their own robotic solutions, products, or cells. So to sum that up, we're trying to provide 3 major contributions, and there is a huge army of startups and established companies out there who are trying to build the foundation to boost robots to really mass adoption. Because from my personal perspective, it's not AI which will drive mass adoption of robots. AI will be required to make a robot solve tasks autonomously. And there are so many smart people out there who will build this technology. But currently, we lack the foundation to start with that at all. So what we're currently trying to achieve is to provide user interfaces which enable you people who might or might not have ever worked with robots. We're establishing a driver system where you don't have to care what's the brand of your robot and what's the brand of your gripper and how this works together. And we are providing engineering tools for all developers out there to start creating in the robotics industry. And I do guess there will be some sort of personal robot in the future. The good question is how this looks like. Me personally, I don't think we will not necessarily have this human-like, two-armed, walking around robot. At the beginning, I think it will be more or less like a PC, something you can, like a robot you can drag around. You put it into your kitchen and can be a kitchen, you can turn it into a kitchen aid. You put it into your desk and you turn it into a 3D printer. You put it into your living room and it can repair your smartphone. I think this will be the very first personal robots we will see to emerge in the next 10 years. And I would like to invite you to get in touch with us if you're interested to start building on top of that, because it will not be one company who will drive innovation in robotics. It will be a huge army of creators, of smart people, of ambitious entrepreneurs who will shape that. What we would like to provide to you is an infrastructure, a platform, and development tools to enable you to do that at all. So thank you very much, and I'll be around if there is any sort of question. And have a great rest of the day.